Hey everybody, we're going to start using our iPad as a learning tool for our notes. I want to give it a try. So what I'm going to ask you to do is follow along with the video that I make and fill out your notes with it as if you're taking notes through this, because we're not going to do this in class. Okay, and we'll see how it turns out. So our first section of Chapter 4, we're going to be dealing with writing and graphing inequalities. So in inequality, we've learned about equations. As you know, with an equation would be when you have one expression equals another expression. You know, it could be a numerical or an algebraic expression, like 3 plus 4 equals 7, or x minus 2 equals 5. Those are equations. Well, an inequality, the prefix in means not equal. So an inequality is a mathematical sentence that compares expressions. It contains less than sign, greater than sign, less than or equal to, greater than or equal to. To write inequality, look for the following phrases to determine where to place the inequality symbol. So here are some of the wording that you will see to kind of clue you in to whether or not you're going to use a less than, a greater than, or whatever sign you're going to have to use. So let's start off over here. Less than. You may see the phrase is less than, is fewer than. This sign, the greater than symbol, it could be written as is greater than or is more than. Over here we have the less than or equal to sign. This would be is less than or equal to. Is at most, that's kind of a important one. I know it seems like it would be at least, but it's actually at most. We'll get to that a little later. Or is no more than. And then finally we have our greater than or equal to sign. And again, it could be greater than or equal to, is at least, again that's a real important one, or is no less than. So these are kind of the wording you would use with these symbols. Alright, so our first example, we're going to look at writing an inequality based on the sentence that we're given. So a number q, we're looking right over here, a number q plus 5 is greater than or equal to negative 7.9. So write this word sentence into or as an inequality. So the first thing I want you to look at would be kind of taking the sentence and breaking it down. So we have a number q plus 5 right here. Well, a number q would be just the letter q, and then plus 5 would just be adding 5. Then we get on to our next part, which says is greater than or equal to. Well, as we knew from page before, that means we're going to use the greater than or equal to sign. And then, of course, we finish it off with negative 7.9. So our inequality would be q plus 5 is greater than or equal to negative 7.9. So let's do the same thing over here. So we have on your own, it says write the word sentence as an inequality. So what I want you guys to do right now, I want you to pause the iPad and I want you to try number 1 and try number 2. When you've finished both of those, then you're going to click the pause button or play button again, and then you're going to see how you did on it. Okay? So we'll take a moment to pause. Okay? All right, let's see how you guys did. So the number x, I'm going to write an x down, is at most. And so for that, I'm going to use my less than or equal to sign, negative 10. So that should have been your inequality that you wrote down. Now again, think of this. If I tell you, or maybe your parents tell you, at the very most, I will give you $10 to clean your room and the bathroom. And so you think, at the most. So does that mean I can get 12? They said, no, at most I will give you 10. Can I get 11? At most I'll give you 10. Could I get 10? Well, yes, you could. That would be the very most I'd give you. That's why at most means this is the most, and anything under that would work as well. I hope that makes some sense to you. Okay, so then our next one we had twice a number y So we're going to do twice means 2 times y. And then we have is more than. So we're going to use the greater than sign. And then we just put our final number, -5 halves. So hopefully that made some sense to you. Let's go ahead and move on to our next page then. Okay, so here we have down a solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution. It's a little different than an equation, because with an equation, typically it has one solution and only one solution. X equals 5. 5 is the only number you can put into the equation to make it true. Well, this is different because we have an inequality. It means a greater than. That means this number and anything bigger will work, or less than. This number and anything less will work. That's what we're going to do with the inequalities. So let's look at the examples we have here. And by the way, an inequality can have more than one solution, as we said. The set of all solutions is called a solution set. So we're going to look at the inequality x plus 2 is less than or equal to -1. So we're given some different inequalities. Some different solutions to test out. And all we're going to do is we're testing them out. So wherever you see the x, we're going to put in whatever number they've given us. So we have a -2. So where I have the x right up here, I'm going to put the -2 right here. So -2 plus 2 equals 0. Is 0 less than or equal to -1? No. So you just put down no. Over here, I'm going to use a -3. So where I see the x, I'm going to put the -3. -3 plus 2 is -1. Is -1 less than or equal to -1? Well, it is equal, so that would be a yes. And then finally, I have -4. So -4 plus 2, that gets us -2. Is that less than or equal to -1? Yeah, it's less than, so that works. So that's how you would test different solutions to see if it would be a solution to the inequality. Okay? Let's look at some more examples here. So over here, it says tell whether -2 is a solution of each inequality. Okay, so every inequality underneath these directions, we're going to plug in -2. So I'm going to go ahead and write this out. So we have y minus 5 is greater than or equal to -6. And so we want to see if -2 will work. So I'm going to put in a -2 for my y value. And so I have -2 minus 5 is greater than or equal to -6. And so -2 minus 5 will get us -7. So go ahead and write -7 is greater than or equal to -6. And is that true? Nope, it is not. So this is a big old no. And we look over for letter B as well. I'm going to go ahead and erase this. And so let's look for letter B. Over here we have -5.5 y is less than 14. I'm going to put in my value for the y. So I have -5.5 times -2 is less than or less than 14. And so -5.5 times -2, that gets us positive 11. Is 11 less than 14? Yes, it is. So our answer is yes. So let's go ahead and take a look at some examples. I want you at this time to pause the video and to test out 3, 4, and 5. I'll be back with you in a moment. Okay, let's see how you did. So we're using, it says tell whether -5 is a solution of the inequality. So we're going to test -5 for every x value. So we have -5 plus 12 is greater than 7. And negative 5 plus 12 is 7. Is 7 greater than 7? Nope. It is equal to 7, but is not greater than 7. So this will be a no. Let's go ahead and try the next one. So here we have 1 minus 2 times p, which is, again, negative 5, is less than or equal to negative 9. And so we have, I'm going to go ahead and do this. I'm going to make this into a plus negative. And I'm going to say that I have 1 plus negative 2 times negative 5 is positive 10, is less than or equal to negative 9. And then 1 plus 10 is 11. And is 11 less than or equal to negative 9? No, it is not. So actually I should do this. I should put a not sign. This means not less than or equal to, and I should have done that over here as well on number 3. That is not greater than 7. So this would be a no. Let's try our last one. So here we have n, which again is negative 5. So negative 5 is divided by 2.5. And is it greater than or equal to negative 3? So when we do this, we divide and we get negative 2 is greater than or equal to negative 3. And it is, so we'll go ahead and put a yes. Doing a great job. Let's go ahead and move on to our next part. So now we're on to the graphing part of this. So it says a graph of an inequality shows all the solutions of the inequality on a number line. An open circle, right here, an open circle, is used when the number is not a solution. Okay? And a closed circle is used when a number is a solution. I'll show you what that means here in a moment. An arrow to the left and right shows the graph continues in that direction. So I think the easier way of looking at this would be this. If I have a variable is greater than some whatever, I'm going to end up using an open circle and it will go to the right. If I have a variable is less than a number, I'm going to have a circle open and it's going to go to the left. Now, if I have a variable is greater than or equal to a number, here I'm going to do a closed circle to the right. And if I have a variable is less than or equal to, I'm going to have a closed circle going to the left. Now again, it's very important. Notice that I have the variable to the left. This only works when the variable is to the left of the inequality sign. And then the direction of the arrow will tell you the direction of the arrow in your graph. But only when the variable is to the left, as I showed right here. And again, if it is greater than or less than, it's an open circle. If it's greater than or equal to or less than or equal to, it's a closed circle. So we see over here, we see that the problem says graph y is greater than negative 8. So since I have a greater than sign, it's going to be an open circle, which is right over here. And since it is greater than negative 8, it's going to go to the right, which you can see right over here. And that's how you would graph it. Okay? So let's have you guys give this a try right now, and we'll come back and see how you did. And I think this is it for your notes once we finish this. Okay?